It is an ordinary Tuesday. Satellites circle the planet in silence. Oceans shift beneath cloud cover. Nearly 8 billion routines unfold without interruption. 900 light-years away, a massive star has already collapsed. You don't know this. No one does. The beam it produced has been crossing the void for 9 centuries. At the speed of light, it arrives the same moment you detect it. There is no warning. There was never going to be one. The sky shifts color, faintly, once. A gamma-ray burst is the most violent electromagnetic event ever observed. In a matter of seconds, a single burst can release more energy than the sun will emit across its entire 10 billion-year lifespan. But it is not an explosion in every direction. It is a beam, a narrow jet of high-energy photons, gamma rays, focused into a cone only a few degrees wide, tight, directional. This is called beaming, and it is the reason most gamma-ray bursts never reach us. The jet points elsewhere. The geometry of the universe protects you, but geometry is not a guarantee. It is just probability. Scientists recognize 2 main categories. Short gamma-ray bursts last less than 2 seconds. According to current models, they form when 2 neutron stars spiral inward and merge. The collision is brief. The jet is intense. Long gamma-ray bursts last from several seconds to minutes. These are associated with the death of massive stars. Stars 30 or 40 times the mass of the sun, whose cores collapse and launch relativistic jets through their own dying layers. Both types produce focused beams that can cross thousands of light years. Both are indifferent to what lies in their path. Not every gamma-ray burst is a threat. Distance matters, angle matters. Both must align. A burst from the far side of the galaxy, tens of thousands of light years away, would likely produce no measurable effect at Earth's surface. The inverse square law dilutes the energy. Distance is a shield, but a burst from within a few thousand light years, aimed directly at this planet, is a different scenario. Scientists estimate that a burst originating within roughly 6,000 light years could cause meaningful damage to the biosphere, if the beam alignment is precise. The threshold depends on the burst's energy, duration, and spectral profile. There is no single safe distance. There is a gradient, and at the near end of that gradient, the consequences are severe. Here is what a direct hit looks like. Step by step, the gamma-ray photons reach the upper atmosphere first. They strike nitrogen and oxygen molecules, ionizing them instantly, silently, invisibly. This triggers a cascade of chemical reactions. Nitrogen oxides form in enormous quantities. These nitrogen oxides attack the ozone layer, not over months, over hours. Models suggest that a sufficiently close burst could destroy 30% or more of Earth's ozone within weeks. Some estimates are higher. The uncertainty is real, but the direction of every model is the same: down. Without adequate ozone, solar ultraviolet radiation reaches the surface at intensities the biosphere is not adapted to. Skin burns faster. Phytoplankton, the foundation of the marine food chain, begin to die. Crop yields fall. Ecosystems that depend on UV-sensitive organisms begin to quietly unravel. The damage is not theatrical, it is chemical, gradual, cumulative. At the same time, the burst ionizes the ionosphere. Radio communications degrade or collapse. GPS signals scatter into noise. Satellites in low Earth orbit experience electrical charging and component failure. Some go dark, permanently. You would not see the beam. Gamma rays are invisible. You might notice a faint shimmer in the upper atmosphere, a momentary glow with no explanation, then static on every frequency, then nothing. After that, the sun finishes the work. Every clear day becomes a slow, quiet exposure. How likely is this? Honestly, not very, and not never. Gamma ray bursts at dangerous range, aimed at Earth or rare events. Scientists estimate a sufficiently close, well-aligned burst may strike roughly once every few hundred million years. Perhaps longer. The data is limited. The late Ordovician extinction, approximately 445 million years ago, has been proposed as a possible gamma-ray burst event. It remains unconfirmed, but the pattern of damage, ozone loss, UV exposure, marine die-off, fits the model. The probability in any given century is vanishingly small, but the universe does not operate on human schedules, and the event needs no warning, no precursor, no countdown. A gamma-ray burst is the deadliest light in the known universe. It crosses the void in perfect silence. It arrives without announcement. And somewhere in this galaxy, one has already fired while you watch this video. You just weren't in the beam. If this changed how you see the night sky, subscribe to Sideral Space, leave a like, share it with someone who still looks up. See you next time.